Well, you asked about, why did I write the book, The Great Cholesterol Con? And that's some time ago now, but I've been studying heart disease for 30 years. And there's so much misinformation. There was so much nonsense being talked about it. I thought I should really try and tell people, well, what actually does cause heart disease? If it is not eating saturated fat, if it is not about cholesterol, people need to know this, or at least they need to be given a different voice, because it seemed that everyone was saying the same thing. At the time, 10 years ago, there weren't many other people saying the sort of things that I'm saying. Luckily, more and more people seem to be, seeing that it's a bit more complicated than they thought. Well, very simply, cholesterol is a chemical compound. You can look it up, it's got little benzene rings and whatever. But what we call cholesterol in our bloodstream is not cholesterol, because cholesterol can't be carried around in the blood, a bit like fats where it won't dissolve in water. So a bit like if you put fat in your washing up bowl, it clumps together and you need to put in washing up liquid to make it spread out. Well, actually cholesterol is carried around in small spheres called lipoproteins. Call them taxis. The lipoproteins come in different sizes. They transport fat, they transport cholesterol, they transport vitamins and other things, but primarily it's fat and cholesterol. So cholesterol is a chemical. It's used to make hormones like testosterone and estrogen and all sorts of other things that keep you alive. It's also in all cells. It makes up the cell membranes, and it's very important in the brain, where it makes up 25% of the weight of the brain is cholesterol. Wow. And it's actually cholesterol is used to make new synapses. If you make a new memory and a new synapse, it's almost entirely constructed from cholesterol. So it's used all around the body. The actual molecule is carried around in the body in things called lipoproteins. So you may have heard of good cholesterol, which is called high density lipoprotein, and bad cholesterol, which is low density lipoprotein. These are just different sizes, little spheres floating around in your bloodstream. Well, you go back many years, the whole idea that cholesterol was damaging goes back over 160 years, where people looked at arteries in the body of people who died, and they found what looked like cholesterol, well, it was cholesterol, in the arteries that had been narrowed, and they were the ones that caused heart disease. So they didn't immediately make the assumption. They said, well, look, where did this cholesterol come from? It must have come from the bloodstream. I mean, they didn't know there were such things as lipoproteins or such as that. I'm always quite impressed they knew what cholesterol was, but they did. And so the idea that cholesterol had something to do with heart disease was laid down a long time ago. And then over the years there was more research. People fed rabbits cholesterol, and they appeared to develop things that looked like narrowings and thickenings in their arteries. And then after the Second World War, heart disease became a real explosion in the United States. I mean, over a 10-year period, 1 in 8 men was dying of a heart attack. It really was like a plague had arrived from nowhere. Whether it had or not come that suddenly, I don't think it had, but I suppose you had the Great Depression, you had the Second World War, and then suddenly it was like, oh my goodness, now everyone's dying of something else. Yeah. So there's a great pressure to say, well, what's causing this? And one of the famous individuals, a man called Ansel Keys, said, I know what's causing this. It's because we eat fats, saturated fats, animal fats. This raises your cholesterol, which obviously you don't have cholesterol, you have lipoproteins. And then this causes heart disease. And that became what we call the diet heart hypothesis, which kind of came into being in the late 50s, early 1960s. And that was in the medical sphere, if you like, that people grabbed onto that. And then over the years, it gained traction, such that in the late 70s, early 80s, the US and the UK created dietary guidelines saying to avoid heart disease and strokes and cardiovascular disease, we should reduce the amount of saturated fats, animal fats that we eat, and eat more carbohydrates. And that's sort of when this whole stop eating wrong way around, stop eating fat, eat carbohydrates came in. And in parallel with that, it was known that diabetics, people with type 2 diabetes, were much more likely to die of heart disease and strokes. So they said, well, if saturated fat causes heart disease in most people, we really need to avoid it in diabetes. So the whole thing then became people with diabetes who used to be advised to eat fat were then advised to eat carbohydrates, and the whole population was advised to eat carbohydrate. So that's a potted version of where it came from, but I think most people would say that's pretty much how it happened. Well, you're talking about where does we call it the bad cholesterol,
Yes.
the low density lipoprotein come from? This does get more complicated to explain, and I try to say to people as simply as I can, and then I see their eyes glazing over, but I'll give it a go again, which is if you eat fat, fat goes down one channel, which is it absorbed from the bowel, the gut. It's packed into a very large form of lipoprotein, which is then directly goes into your bloodstream, and it travels around your body losing its fat load. As it does so, it shrinks down and down and down and down till it's almost disappeared, and a very small part of it goes back into your liver.
Right.
So the fat you eat has nothing to do with the bad cholesterol.
Right.
But if you eat carbohydrates, we'll talk about, forget protein for the minute, that gets far too complicated, but if you eat carbohydrates, which is basically bread, potatoes, pasta, all the things we're advised to eat.
Yeah.
At one point, the healthy diet used to say it had Coca-Cola cans on it. I wonder how that happened. Then basically it's all converted to sugar, simple sugars, usually glucose, some fructose. That travels into your liver, and your liver would store that. Normally there's a storage form of glucose called glycogen, which is just lots and lots of glucose molecules all packed together. You can store about 500 calories in your liver. Sorry, your liver's on this side. That's your pancreas. 500 calories in your liver. I'm thinking the other way around. And you can store about 1,000 calories of glucose glycogen in your muscles. After that, your body's full. So that's about 4 Mars bars, and your body can't store any more glucose.
Right.
So assuming your body's got glucose stores, your liver has to do something with this excess glucose that's come into it. And the only thing it can do is it creates fat from it. It's fatty acids, fats.
Sure.
We'll assume it's the same thing for the sake of this argument. Those fats are then bound into what they call a triglyceride, which is 3 fats in it, attached to a glycerol. They're then packed into another type of lipoprotein that the liver makes called a very low density lipoprotein. People have probably heard of triglycerides, like your triglyceride level is high or low.
Yeah.
Triglycerides are actually very low density lipoproteins. Just to confuse everyone, they're called the same thing. The way that fats are stored is 3 fatty acids. That's a triglyceride. A very low density lipoprotein is a triglyceride. But anyway, the very low density lipoprotein travels out of the liver, travels around the body, losing fat. And as it does so, it shrinks down in size. And it eventually reaches the size of a low density lipoprotein. So it's turned from a VLDL, it becomes a thing called an intermediate density lipoprotein, low density lipoprotein, at which point almost all of it is reabsorbed into the liver to be reused for various things. Some of it floats around in the blood, and that's your low density lipoprotein, and that's the one that is supposed to cause heart disease. And that is, so when people say, what's your cholesterol level? It's not actually even your low density lipoprotein level. It's your high density lipoprotein level, your low density lipoprotein level, some of your very low density lipoprotein level, all added together to create a figure. So when someone says your cholesterol level is 5 or 6 or 4 or 7, that's what they're talking about. It's not cholesterol, it's various lipoproteins linked together, which is, as well as one of the complication factors is obviously if high density lipoprotein is supposed to be good and low density lipoprotein is supposed to be bad, and you have lots of high density lipoprotein, you could have a high cholesterol level full of good cholesterol. Well, the function of a low density lipoprotein, if you said it was the size of a tennis ball, and a high density lipoprotein would be about the size of a ping pong ball, possibly. They do different things in the body. The primary function of a low density lipoprotein, because it shrunk down from being a very low density lipoprotein, is as a cholesterol carrying molecule. So it carries cholesterol about. Now cells that need cholesterol will pop out a receptor from their cell membrane, which sort of comes out like that. Right. And the LDL comes along and it goes hello, and it clamps together and it pulls the whole thing into the cell. So the whole thing, the LDL receptor plus the LDL is pulled into the cell, and then it's all broken down. And the cholesterol is used for various things the cell needs it for, and the rest of the, well, I don't quite know what happens to the rest of the receptor. Interestingly, there's a new set of drugs that have come along that block the breakdown of this receptor, so it keeps popping out, so it keeps pulling more LDL in, so that cycle happens and your LDL levels drop very low. But the primary function of LDL is to carry cholesterol around, which the body uses. It's got some fats in it as well and other things, but that's what it's for. So an HDL molecule is a very different beast and if you look at it, it's very difficult even to work out where it comes from. Some of it seems to be produced in the liver, some of it's produced in the GI tract, and their role is, it has many different roles, but I'll try and keep it simple. The conventional thinking is that HDL attracts cholesterol that's floating around, and a bit of triglyceride in it, pulls it out of atherosclerotic plaques. They then expand a bit, and then they transfer the cholesterol back to VLDL, which is then taken back into the liver and taken out of the system. So that's one idea. But the other thing that HDL does, they've got proteins attached to the side of them, which are, if you like, receptor devices. So these proteins are floating around, and then they keep locking onto other lipoproteins and other cells around the body, and then they start transferring things back and forward between lipoproteins. So HDL, slightly complicated. Well, slightly complicated. I've read papers where there's 42 different types of HDL, right, all doing different things, and some are good and some are bad. And there are some papers showing that people with higher HDL levels are more likely to die of heart disease.
So they're not all good.
Yeah, well, you're entering a world from which you will never leave if you start looking at this. My own belief is that HDL is a sign of underlying, if your HDL level is low, it means you've got insulin resistance. It means you're pre-diabetic, and it's a sign of that, all right? And if your HDL is high, it means you don't have that. So actually, we're just looking at a sign of physiological health when we have HDL. The other thing that HDL is, it transfers proteins to VLDL as they leave the liver. As they do so, they effectively disintegrate. So if your VLDL level goes up, your HDL level will de facto go down. These two things, they're connected, all right? And if your VLDL level comes down, your HDL level will come up. So when people talk about dyslipidemia with diabetes, dyslipidemia usually means a high VLDL and a low HDL, all right? And then if that changes, it goes the other direction. Right. That's usually an underlying sign you're doing something right. Okay. It's not a causal thing, but that's, anyway, there's several more people believe that, but other people believe different things. So I'm just giving you the lowdown on that, if you like. Yeah. Cholesterol, LDL, and diabetes are not particularly closely linked together. If you develop diabetes, your LDL level won't tend to do very much. It won't change. Your VLDL level will go through the roof, and your HDL level will drop through the floor. So you have what they call some people call a pro-atherogenic, a pro-heart disease spectrum of lipids. All right. But moving back to the original question, why is diabetes on the increase? This is to an extent why I became interested in this whole area, because it's clear that the dietary guidelines that were introduced in the early 80s have been a really powerful factor for driving diabetes, because people were told to stop eating fat and start eating carbohydrates, and that is what they've done. Now, if you understand the physiology, human physiology, not everyone, and if you're fit and you're slim and you're active and all these things, you can eat as much carbohydrate as you like virtually, although some people can't. What happens when you start eating a lot of carbohydrates, they're all turned into sugar. The sugar is converted to fats in your liver, your VLDL goes up, your HDL goes down. But eventually, of course, what does your body do with all this excess sugar? It starts to go, I haven't got nowhere to put this. I can't put this anywhere. So what happens is eventually your insulin level rises to try and force this process of pushing sugar into cells. And then some people use the term insulin resistance. I don't like it, but it's a reasonable shorthand. Because effectively, your insulin says, I give up. You keep putting sugar into me. I keep trying to get rid of it, and now I'm full up and there's nowhere to go. So the blood sugar starts to rise. Right. Well, of course it starts to rise. And then what's the advice we give to people who've got diabetes? Eat sugar. And you go, that's sensible. So what happens? They eat sugar, their sugar levels go even higher. So we give them drugs to drive their insulin level up even higher. We start giving them insulin, and we drive and drive and drive the system. And eventually the whole thing just gets stuffed. Could I use an example? There's a condition which you'll never have heard of and is very, very rare called Burden-Ellis-Siepp lipodystrophy, where people have no fat cells in their body. Right. Now you might think, what a wonderful thing. No, not at all. Because the first thing you've got to ask is, I ask doctors this question. I say, how many people with Burden-Ellis-Siepp syndrome do you think have type 2 diabetes? And they all say none. And I say, you're not thinking about this right, are you? Think again. They can't store fat. So if they eat sugar and it's converted to fat, or if they eat fat, where does it go? It has nowhere to go. So I'll ask again, how many people with Burden-Ellis-Siepp syndrome have got type 2 diabetes? The answer is they have all got type 2 diabetes.
Wow.
Because they have nowhere to store the excess energy. And there is an argument going around, and it's an argument I follow, which is if you can store fat forever, you will never become diabetic. You'll just get fatter and fatter and fatter. There's no back pressure. So sumo wrestlers, who are the fattest people on the planet Earth, have no diabetes. None. Until they stop exercising, and then all hell breaks loose. Sumo wrestlers deliberately put on fat, and they eat carbohydrates to do that. They eat a very high carbohydrate, low fat, brothy, horrible thing. And then they put on fat, and that's how they do it. Right, but what they are not doing, because they're exercising like mad as well, they're burning off their carbohydrate stores. So when they eat carbohydrates, they can be stored, and then it can be burnt off, and the excess is turned into fat. Stop exercising, forget it. So you have two examples. The fattest people in the world are sumo wrestlers. They have no diabetes. The thinnest people in the world have BIRD and LACF syndrome. They all have diabetes. So people are looking at this wrong, but the answer is sort of the same. If you start putting on weight, the problem is when you can't put on any more weight. And some people have a limited amount of fat cells. Some people can, you'll have seen people who like, I weigh 150 stone and I can't move, and they're, quite often these people are not diabetic. They're not diabetic because they don't have any problem with storage. They just keep storing and storing and converting and storing, and they've got a fantastic storage system. All right, it's the other people who start running into problems. So I mean, increasingly you do see quite slim people coming and saying, I've got type 2 diabetes, and that goes against what we're told. The answer is they can't really store it properly, and then they become diabetic. All right. Now what these people need to do is just to stop eating sugar, stop eating carbohydrates, because your body doesn't deal with that the same way as eating fat. Your insulin level powers up, starts forcing it into other fat stores in your body. There's what they call visceral fat around your stomach, and that's the bad fat. So we have created, the medical profession has created the diabetes epidemic. We've made it. And now, because there's a refusal to accept that we should be advising people to eat fat, oh my goodness, they'll all get heart disease. Well, this is nonsense as well. There's no evidence from anywhere. When the dietary guidelines were introduced in the UK in 1983, there was a researcher who looked back and said, well, what was the evidence to support these guidelines? And do you know how much evidence there was to support these guidelines? There was none. There was no evidence at all from anywhere. It was just figured that was the case. It was just
figured out.
People just said, well, it's saturated fat. This story just became believed. It had no evidence to support it. It never has. And since then, it still has no evidence to support it. A huge study carried out by Salim Youssef, who's a very widely respected researcher in cardiovascular medicine, called the PURE study. And he said that, you know, there's clear evidence that the macronutrient, a macronutrient being fat, sugar, or carbohydrate, the macronutrient that drives diabetes and cardiovascular disease is carbohydrate. Right? Not fat. There's no evidence for that. There is none at all. If people find this hard to believe, I say to them, well, go and find it then. Show it to me, because if you can find it, I find it hard to believe. I've been looking in this area for 33 years and have failed to find any evidence. If you think you can find something, bring it to me and show it to me. And they write guidelines. The Swedish health authorities 10 years ago looked at the evidence and came to the conclusion there is no evidence that saturated fat is associated with cardiovascular disease. Right? And yet we are still told in this country saturated fat causes heart disease. You say, where does this come from? And they say, well, if you eat saturated fat, your LDL level goes up. Well, the answer is, it does a bit, but your HDL level goes up a bit as well. In fact, more than your LDL. And according to that, your risk of CVD should go down. There is just no evidence.
Right.
And people will not pull back from this position. There's so much vested interest in it. And the evidence that fat makes you fat is also complete nonsense as well. There's no evidence for that. The evidence is not as strong as some people would say that it's all carbohydrates. You know, I believe people have got a bit too bandwagonish. Everything's to do with carbohydrates. But, you know, if you're looking for a culprit, if you want to find a culprit, and people say, oh, eat fruit, and say, fruit is full of fructose. The worst possible form of sugar you can eat if you want to avoid, if you want to become fat, is fructose. That is designed to make you fat. Right. I think nature designed it to make you fat because fructose is in fruit. Fruit comes out in the autumn, and animals want to get fat in the autumn. Yep. And grizzly bears and all these animals seek for it and put on huge amounts of weight. A polar bear puts on 500 kilograms of fat before they hibernate, as does a grizzly bear. You know, they're trying to get fat and they choose the food to make themselves fat, as do sumo wrestlers. All right, so fructose is not bad in and of itself, but nowadays, what they call high fructose sugars and sugary drinks are flooding the markets. They're very high in the, they put in the sugar tax recently. Well, what difference does this make? I don't know. But we have caused this problem. We have made it. The medical profession refuses to back away from this position and will just refuses to look at any evidence to the contrary. It makes me kind of pissed off. No, more than kind of pissed off. Because I just deal with the science, if you like. I'm not interested in running a fad. If it proved to be the other way around, I'd say it's the other way around. I don't think I have any problem changing my mind. But right now, we have an epidemic of diabetes and obesity. We know what the solution is, and we're telling people to do the exact opposite. This is just the opposite of sensible. It's just, take a deep breath, count to 10. It's just nonsense. I think when you talk about primal man and what did we do, how did we live, I'm sure that we lived was whatever was around we ate, right? And then it became a kind of, we adapted to what it was, wasn't it? Some animals can't put on weight no matter what you do with them. Hunting birds of prey, they put on an extra ounce and they just stop because they know they can't fly properly. Some animals put on weight because they know if they put on weight in the winter time, that's good because you've got to get through the winter. So, primal man probably, well, fruits came out, they were there, they ate them. They probably didn't care they were putting on weight. That's a great thing, thank God for that. There is a population in America called the Pima Indians. I don't know if you've heard of them. Northern Mexico, southern states of America. 92%, if memory serves me, of these people have got type 2 diabetes. Wow. And that happened once they started eating a high carbohydrate diet. Now, what happens with these people actually is very interesting, and it's very rarely talked about, is even when they're young and they're not diabetic and they're not obese, I mean, they've got like 86% obesity, 90, whatever, it's huge numbers, is that they overproduce insulin when they're given a glucose meal. So we might produce 5 and they produce 10. Now what the insulin does is then that drives fat storage. So these people are primed to store fat. And they store it really efficiently. And if you give them a high carbohydrate diet, they just become enormously fat and diabetic. And you can see that they're designed to do that. So there's clearly some people who are not designed to do that. Some people who you can't get them to put on weight no matter. I don't know if you see my son, he eats everything known to man in vast quantities, does nothing and looks like a stick insect. And I think, you bastard. Lucky. And I know I drink too much beer, but I do try to stop it. But no, the answers are out there, they're very clear, but because the dogma is you mustn't eat fat, and fat makes you fat, and sugar is good for you. Well, they don't say sugar is good for you, they say carbohydrates are good for you. We've got stuck with this model. And I don't know how you break it. I mean, it needs to be broken, it needs to be disintegrated and stomped into the ground, but there we are. Is it dangerous if your cholesterol levels are too low? I think it's dangerous, and then you have this argument, well, what is low and what's high? And you'd think that would be easy to answer. The evidence, and I co-wrote a paper last year, which went out in the BMJ, showed that once you reach the age of about 55 to 60, who knows exactly what age, because people do those studies at different ages, that people with lower cholesterol levels live shorter lifespan than people with higher cholesterol levels. Wow. And as your cholesterol gets higher as you get older, the longer you will live. This is true of every population that we managed to look at, every study we managed to look at. And if your cholesterol level starts to fall, that's a particularly bad sign. And as a counter argument that your cholesterol level falls because you've got another illness that makes your cholesterol fall, and there's some truth to that, and that if you've got cancer, your cholesterol level will tend to fall. But of course, depending on how long, the argument at the moment, some people seem to say, well, if your cholesterol level's 30, falls 30 years before, there's no disease that's going to do that. You've got to be almost in terminal cancer before your cholesterol level falls. There are some other conditions, as forms of hepatitis, where your liver can't produce the cholesterol, etc. But in general terms, if you remove all that out, a lower cholesterol level is associated with a higher mortality. In other words, the lower your cholesterol level is, the shorter you will live. And that's, I can't think of any study that I've seen where that has not been the case. How are cholesterol levels measured? You open another can of worms. All these questions seem very simple, and you look at them and you think, oh my God. In fact, LDL is not measured in the United Kingdom. You won't get your LDL level. You can ask for it specifically, but in general, they'll give you your total cholesterol level, which includes your LDL, your VLDL, and your HDL. You might get your VLDL and your HDL. What they tend to measure in Britain is your HDL and your VLDL level.
Right.
And what's left, they say, is your LDL level. And that, there's a calculation called the Primal equation, which uses these things. It's not fantastically accurate, but that's how they do it. Now, if you wanted to know exactly how much LDL you had, you have to get your blood sample, you have to ultracentrifuge it to separate out the different lipoproteins from each other, and then you can actually say exactly how much LDL you have got. There's some argument at the moment that we measure LDL cholesterol, LDL-C, and actually the number of particles of LDL is what's important. And that's a completely different thing. And we've never measured that in this country, and we don't measure it.
Never.
It's not part of your test. The LDL's never been part of your test.
Oh.
So in fact, if you look at the risk calculator, which I showed you earlier, the Q risk calculator, it doesn't ask you what your LDL level is. It asks you what your total cholesterol to HDL level is. Now in the States, they actually do the LDL level. They say, what's your LDL, HDL level? Now how they're doing that in the States, I don't know. They must still be using this Friedwald equation, which is pretty inaccurate. So a lot of it's a guesstimate. You know, people say, oh, my cholesterol's 5.27. I go, well, it could be anywhere between 6 and 4. You know, and if you took it tomorrow, it would be, it is really, people have sent cholesterol samples to 2 different labs simultaneously, and they've had differences of 30 to 40% in the results they get back.
Wow.
It is not a very, I mean, you get a finger prick test, you go, right, that's really going to tell you what your cholesterol level is. They're making assumptions and they're guessing. So it's, and it depends on whether you've eaten beforehand, because if you can't eat, because if your VLDL level is high, it will completely skew the whole result. Because in part you're calculating your LDL off your VLDL level, and if you've just eaten a high carbohydrate meal and your VLDL level is this, what is your cholesterol level? What's left? Well, actually, you're only supposed to measure, you're supposed to take your VLDL level and divide it by 2.2. I mean, it all gets, you know, forget about the complications of it. I think it's pretty inaccurate. It varies much more than people might believe, just depending on when you've eaten and not eaten and stuff like this. Different labs will give you a different result. So it gets far from simple. If you eat a lot of cholesterol in eggs, the highest cholesterol containing food is an egg. And does that make your blood cholesterol or LDL or VL or whatever bit you're measuring go up? The answer is no, it doesn't. And in fact, that was known 60 years ago, because the man, Ansel Keys, who started the whole process, his initial hypothesis was eating cholesterol raises your cholesterol. So he then fed human volunteers lots of eggs, and it made no difference to their cholesterol level. So he then said, oh, it's not that, it's saturated fat. So he immediately changed the hypothesis. Why doesn't it raise your cholesterol level? Because the human body has this amazing thing called the feedback system. Your liver produces about a gram of cholesterol a day. There's varying estimates, but we'll call it a gram. An egg, a large egg, contains about 185 milligrams of cholesterol. So that's about a fifth or a sixth. So if you eat 6 eggs, that would give you as much cholesterol as your liver would synthesize in a day. So the body says, I'm getting all this cholesterol for free out of eggs, I'm not going to make any more. Why would it bother? It doesn't. It's the same with everything in the body. It down-regulates. You know, if your blood pressure goes up, your body does things to bring it down. If it goes down, it brings things to go up. If your liver is getting enough cholesterol from the diet, it stops producing its own cholesterol. You say, well, what if you ate 12 eggs? Then it would go up. You go, well, actually it doesn't. They've looked at this. Because the body just starts saying, well, I don't need all this cholesterol, I'm not even going to absorb it. It switches, there's various receptors and really complicated stuff in your stomach, which basically says, we've got enough cholesterol in the system, we don't need it. Instead of coming in, it just comes in and goes out. Wow. And then actually the body will start shedding the cholesterol back into the system, because most of the cholesterol the liver produces goes into the gallbladder, where it's produced after you've eaten. And it's actually, cholesterol is bile. You might have heard of bile, salt's bile. And it comes out of the gallbladder. It actually combines with fats, otherwise fats couldn't be absorbed, combines into things that are then absorbed. well, the liver will just start shoving more cholesterol out, and it will just start moving through you and out. So it will come out as the other end. You won't even know it, but it's happening. So the body will adjust it, can adjust it. I don't know if there's a maximum. If you ate 50 eggs a day, well, if you ate 50 eggs a day, you'd be constipated for one thing. Yeah. If you ever tried eggs, it's a good way of treating diarrhea. No one could eat that many eggs, but you know, there were people who lived on St Kilda in Scotland who lived almost entirely on eggs from the birds that nested on the big cliffs there, and they were eating 5-10 eggs a day. You know, there doesn't seem to be a limit, and there are a few people who've got a problem and it rises up. The vast majority of people, you can eat all the cholesterol you want, and it will make no difference at all to anything at all. And in fact, a big study's just come out from China. 500,000 people who eat eggs regularly are less likely to die of heart disease. You know, this is the kind of evidence that makes you just think, well, why do you keep saying cholesterol's bad for you? It's not bad for you. It's a vital, vital substance. Why do you think your liver spends a large amount of energy and time making the damn stuff? And why does your brain need so much? And why do you need to make hormones out of it? And why? It's just, you know, it just strikes me as completely ridiculous to demonize a substance that is absolutely critical for our health, without which we would instantly die. And yet there we are. That's how medicine is now working, you know. How much cholesterol does it take to build and maintain a healthy human being? The exact same amount as the liver produces, one would imagine. Because our bodies are not passive objects. They don't just sit around going, we have eaten fat, we will become fat, we've eaten cholesterol. No, we're always looking to do it. We're always looking to produce the right amount of stuff. I mean, if you give a statin that blocks cholesterol synthesis in the liver, what happens is you can see the body really, really fighting and fighting to force that system to produce more cholesterol. And it's clearly trying to overcome something it really doesn't want to have happen. And you know, you start throwing a spanner into the works. I mean, I talk about the statin hand grenade. You know, we've got this incredibly complicated machine here, fantastically complicated, producing all sorts of things. You know, if you block cholesterol synthesis, you don't just block cholesterol synthesis. You block production of about 10 other things, because there's the stem of cholesterol synthesis turns into, you know, a tree, if you like, of things. You cut off the trunk, and all these other things get knocked off as well. And you're throwing a hand grenade into the liver and going, well, we hope it's going to work, but, you know, heads down. I can't believe that people don't just die the moment they're given statins, for example, because you look at what they do and you think, this can't be good, you know. And there's a lot of evidence from the studies, if you decide to look at it, that a lot of nasty things happen. So is cholesterol essential? Well, there's a substance called coenzyme Q10. You may have heard of it, you may not have. Yeah. But coenzyme Q10 is used by the body as a coenzyme in the mitochondria to produce ATP.
We actually manufacture coenzyme Q10 as a supplement.
Well, coenzyme Q10, when the first statins came out, Merck put in a patent to combine a statin with coenzyme Q10 because they knew from their experiments that it knocked coenzyme Q10 production on the head and caused potentially a lot of problems, muscle pains, lack of energy, potentially heart failure. Your heart needs a lot of energy. So what you're doing is you're hampering an absolutely critical substance in your body and then going, well, that's not going to cause any harm. You know, a number of people I speak to, when they've been on a statin, they feel like everyone's turned everything down by 20%. They can't go out for a walk, they feel tired, they can hardly stand up, the muscles are less strong, and you think, well, exactly, that's what coenzyme Q10, lack of coenzyme Q10 does for you. There are some people, very, very rare condition, coenzyme Q10 deficiency. There's about 10 people in Britain with it or something. What do these people suffer from? Well, they suffer from muscle pains, joint pains, lack of energy, heart failure, all the things that coenzyme Q10 does. Yep. And then statin manufacturers say, or the researchers say, oh, coenzyme Q10 doesn't cause any, you know, give statins doesn't cause any of these things. And I go, well, how can it not? You know, how can it not? How can people remain healthy when they're having vital substances chopped on the head? I know this is not cholesterol, but it's the same sort of thing. Is cholesterol essential for the functioning of the human body? Yes, of course it is. There's a condition called Smith-Lemmy-Opitz syndrome, where it's a genetic condition where you don't produce enough cholesterol, so don't synthesize enough cholesterol. So what happens to these children? Well, a lot of them are born with microcephaly, in other words, their brains are very small. They've got hollow encephalopathy, meaning their brain doesn't join together properly. They've got liver failure, they've got nerve problems, they die, all right? So cholesterol, you know, at what level is that? That's quite low, but we've now got new agents that can lower the cholesterol level below this to a level where the nervous system fails to function or develop properly, and we're trying to drive cholesterol levels down to this level. Okay, it's adults, so the system's already in place, but we know they're vital for you know, nerve conduction, nerve health, brain health. The brain produces its own cholesterol. It can't absorb it from the bloodstream. There's a barrier in your brain. So there are cells in your brain that produce cholesterol called glial cells, and they're synthesizing it and pushing it out to keep the neurons alive. We know that if you stop the production of synthesis of cholesterol in the brain, synapses are not formed, and the animals just don't work, and that work's been seen. And we're saying, oh, let's just throw a spanner in the works of cholesterol production of human beings. Oh, fantastic. You know, how ridiculous is this? And I see problems with people, and I see increasingly, you know, they come to me saying, I've got this, that, and the next thing, and yet the mainstream researchers are saying statins have no side effects, or 1 in 10,000 people, or they're imagining they're having side effects. It's just... What are statins? What do they do? Statins are designed to stop the body producing cholesterol. Cholesterol is a 36-step enzymatic process, enormously complicated and long. It starts, however, down at one level, and there's an enzyme that converts one thing to another thing. I won't go into the chemical details, but basically at this level, statins lock onto that enzyme and stop it working. And so basically cholesterol synthesis is reduced by however many percent, quite a lot. It doesn't completely block it. And that's what they do. They block the synthesis of cholesterol, but obviously they block it in the liver, which is mainly where it's produced. All cells can produce cholesterol. Glial cells produce cholesterol. Some statins are not very good at crossing into the brain, some a bit better. So they block the cholesterol synthesis in all parts of your body until they clear out, all right? And that's what they were designed to do. They were discovered in red yeast rice in China, a substance called monocolin K, and the first statin was an exact copy of monocolin K, which is called lovastatin. They've all got different structures now, but that's basically how they all work. Now, there were about, I think there's about 8 of them in total. I was, years ago, people used to ask me this question, I was much more circumspect because of the pressure on you to say certain things, but nowadays I'm very much, you know, is it worth it? Is it worth it? I just don't believe that it is for anybody. I think the data themselves from the clinical trials has to be looked at more closely. Someone did an analysis in the year 2005. New regulations came in on clinical trials, which said it used to be before you started a clinical trial, you didn't need to tell anyone you were doing it. You didn't need to tell anyone what you're studying. You didn't need to tell anyone what endpoints you were looking at. And after 2005, you needed to do all of those things. Before 2005, there's a lot of positive statin studies. After 2005, there are none. And I thought of starting a campaign which was a bit like the campaign that all athletic records should be taken from expunged from before 2005 because so many people were taking drugs. We don't know which ones we can rely on. Yeah. I was thinking of starting my own. Let's take all the clinical trials before 2005 and just ignore them because frankly the likelihood of bias is so great that they were probably not true. So let's start again. I mean, this is never going to happen because almost every drug that we now use would have to be reanalyzed and no one's going to do that. But I think we have to create the realization, you know what? This stuff, can we really trust it? Can we really trust that it was done properly, all right? Can we trust that the evidence is correct? And I don't think we can. And we talked earlier about the quality outcome framework system in the UK whereby people are not just cardiovascular disease, but diabetes and all sorts of other medical interventions. You get paid as a doctor for doing them. So you get paid, it comes to billions of pounds for each individual GP, for each individual thing. It's like 20p, but you add it all together, it gets very big very quickly. And when the quality outcome framework system came in, everyone said this is fantastic. It'll have great benefits on health because we'll be giving all the people the correct drugs and treating everything correctly. Well, Well, I predicted in 2008, wrote an article saying this will reduce life expectancy because we don't know the evidence for these trials, and equally, we don't know what happens when you combine all these drugs together. We could be doing a lot more harm than good. And it now turns out that life expectancy is falling in this country. It's been kept kind of quiet. And I know that when Jeremy Corbyn said life expectancy is falling, everyone jumped on him and said, what an idiot. He doesn't even know what he's talking about. Actually, what he was telling was the truth. And in fact, the first 3 months of this year, 25,000 more people died than was expected. And this wasn't a particularly bad year. There was no flu or anything particularly. So something is causing elderly people not to live as long as they did. And in my opinion, it's what we call too much medicine, polypharmacy. Let's start with the too much medicine #1 drug, which is statins, and say, can we get a real look at this? Can we stop people taking, so many people taking this medication?
What should we avoid?
Well, of course, there's no such thing as fats, as fatty acids. And the ones that we were told to stop eating were basically saturated fats, which are mainly animal fats. A saturated fat is so called because every carbon atom in a saturated fat has hydrogen attached to it. So there's no spaces to put more hydrogen in. If it's unsaturated, it means it's a space with a double bond and you can put a couple of hydrogens in there. Polyunsaturated means there's more than one space. And essentially, it was decreed that polyunsaturated fats, which are usually oils, because if fat is unsaturated, it bends, and if it bends all over the place, it basically becomes a liquid. That's a super simplified version. But so it's polyunsaturated fats and things like, mainly from plants is where you'll get a polyunsaturated fat. Whereas the saturated fats tend to come from animals, although you get omega-3 unsaturated fats, which come from fish, because if they have very stiff fats, they can't wiggle, so they can't swim. That's why they've got a bond in them. That's a super simplified version, but it's effectively true, all right? And then those are supposed to be healthy. It's the irony is, of course, that companies like McDonald's were told not to cook their chips or fries in saturated fat, which was mainly beef tallow, which is stearic acid, right, which tastes particularly delicious. But anyway, so they stopped doing that, so they started it, and then they started frying them in trans fats, because that was the cheapest thing to do. And a trans fat is an artificially created fat where the bond is artificially created, put it that way. It's a bit complicated to explain. Now, nature doesn't produce trans fats, but we were all told to eat trans fats, and it's now clear that trans fats are uniquely unhealthy. They increase the risk of cancer, diabetes, heart disease. They've been banned in many countries. So the first thing that we tried to achieve with changing saturated to polyunsaturated fat created a health problem instantaneously. Is there any evidence that polyunsaturated fats are unhealthy? No. Is there any evidence that they are healthy? No, not compared to saturated fats. You've heard of monounsaturated fats, that's where only one bond is missing. Oh, it gets horribly complicated, yes. But essentially, there isn't really an unhealthy fat. There's some people who've said if you eat too many omega-6 fats, which means you're missing a bond 6 from the end, rather than omega-3 fats where you're missing one 3 from the end, that can trigger some inflammatory processes that can lead to diseases. I think if you just eat omega-6 fats, there is some evidence that you can trigger inflammatory things in eczema and bowel disease. It's not clear, I'm not hugely 100%, but I think the evidence is that that's an unnatural type of thing to be eating, and your body ends up sticking all these omega-6s into various cells and membranes and things, and it does change how the body sees itself, so you can get some autoimmune processes triggered. So don't eat too many omega-6 fats, not from a heart disease perspective necessarily. There's some evidence that omega-3 fats are healthy. It's not hugely strong, but it doesn't seem to be anything to do with cholesterol, LDL in your blood. It does seem to be that actually they're quite good for making your blood clotting system a bit more efficient. And that's another very complicated argument. But they sort of found healthiness and unhealthiness, but nothing to do with the way they thought they were ever going to find that they happen. Would I advise people to eat or not eat monopolysaturated, fully saturated fats? Not particularly. I wouldn't be bothered. I think that there was a recent study in the BBC, which you might have seen with Michael Mosley. It was actually published in the BMJ, where they fed people different types of saturated fats. There was coconut oil, butter and olive oil, and they looked for the effect on LDL and HDL and found that the highest saturated fat is coconut oil. It had no impact on LDL and raised the HDL. Biggest study ever done. The olive oil, which has more saturated fat, olive oil has more saturated fat in it per gram than a steak, and yet we're told it's healthy because it contains unsaturated fats. We're told so many things that are just nonsense. That had no effect on LDL, slightly raised HDL, but butter, which slightly raised the LDL and raised HDL. So they gave people 3 lots of saturated fat, and if you used the risk calculator, it would have reduced the risk on that risk calculator. Hugely? Not hugely, but you know, I wouldn't have expected it to be huge. But essentially, such studies as there are, they become contradictory very rapidly. You can find studies all over the place. But I would say it doesn't matter too much what type of fat you eat, and I wouldn't worry about it, and I don't worry about it. The world is obsessed with telling us that saturated fats are unhealthy, because that is just a message that has gone on and on and on. And I think if you quote the Red Queen from Alice in Wonderland, if I say a thing 3 times, it is true. No, actually, it's from Hunting of the Snark when I say a thing 3 times, it is true. Lewis Carroll had a great insight into human thinking. There is no evidence for it, it's just something that lots of people say. And it's amazing how powerful that is, you know. And once it becomes the established meme, it's very difficult to shift. You know, I've become much more interested recently in why do people think things rather than what it is that they think. And once they've stuck on thinking a thing, how can you change it? Have you ever seen the film Inception?
Yes.
Yeah, great film. The most powerful parasite is an idea. Stick an idea in someone's head, get them to believe in it. By golly, it's difficult to shift it. It's not there because the science says it's there. It's not there because the evidence says it's there. It's just there because everybody's said it 500,000 times a day for the last 60 years, and it's stuck. That's it. There's no evidence. I think there is also quite a strong emotional link in that, you know, if you eat fatty stuff, you can see that people are fat, and then there's fatty stuff in the arteries, so it kind of makes sense. Fatty, gooey stuff. You look at an apple and you polish it up, and a nice piece of fruit and a vegetable, and it almost seems like the purest common sense. That's healthy, that's not healthy. So I think there's an element that it's almost common sense, and that's a very dangerous thing. You know, when you look at the physiology and the biochemistry, it doesn't make sense at all, but on a very superficial level, it makes a lot of sense. Fatty, gooey stuff must be bad for you. People are fat, we don't like fat, you know. There's an emotional trigger. I think the strong emotional trigger is there. Once you've got a strong emotional binding, you know, fruit's healthy, it's nice, and it makes you feel good. We don't like to have that upset. Fat, that's horrible stuff, we don't like that. You know, we don't want someone coming along and saying, actually, it's quite healthy for you. And so we're up against a number of things. I do use a quote sometimes of someone looking at sewer pipes and someone saying, oh, they build up with fat down there and it's gory, it's just like gorging on fat and chicken and bacon, and it all builds up in a big lump. And when you look at it, you think, yeah, I can see that, you know. You can't imagine if you put an apple core down there, it's going to form a big horrible nasty lump. So I think there's an emotional thing as well that triggers into it. We can see it. People can see it in their mind. Fatty stuff into your stomach, fatty gooey stuff into your arteries, that's it. And I think when people have got a story and an image in their minds like that, it's incredibly difficult to shift it. So somehow you have to shift it, you know. That's difficult. I've been battling away against it for some time, for 33 years. Well, not 33 years, but for a long time I've been trying to battle away against it. But I'm aware that people keep shifting back to it. You know, if I'm eating a salad, people go, oh, that's healthy. I go, no, it's not. I just fancy eating a salad, you know. Whereas if I eat a burger, if you're going to McDonald's, people, how can you eat at McDonald's? I say, well, what is there in a McDonald's that's particularly unhealthy? There's a bun. You've eaten a bun in your life. There's a bit of burger, and as far as I'm concerned, it's quite a healthy burger. Probably the dangerous bit's the chips and the Coke that you're eating with it. Well, that's the unhealthy bit. The bit you think's unhealthy is the healthy bit, and the bit you find yourself just virtually going up to brick walls and banging your head against them, going, if people can't understand science, they can't just forget it. You know, if they want to die of heart disease, if they want to be unhealthy, they can just do it. I'm giving up, you know. And then I take a deep breath and think, no, take a breath, you know. Try and help people to understand. They've been told the wrong thing by so many people for so long. Of course they don't understand it. How can they understand it? You know, I'm still a lonely voice in the wilderness. Occasionally when I shout hello from the rooftops now, somebody shouts back. You know, and I go, oh, there's somebody else out there that thinks the same as me, that knows it, that's looked at the evidence, and you think, oh, it's like an oasis of calm in amongst just a sort of a raging ocean of stupidity that's going on. And you just think, all we can do is keep shouting from our little rooftop and hope more people join in. It is beginning to happen. I think that to say that heart disease is about stress is complex, but there is no doubt. In fact, my favourite graph, I said that when I was having a talk, I said my favourite graph, and my daughter said, that's the most boring thing I've ever heard anyone say in my life, my favourite graph. I said, you're an obsessive compulsive. I said, well, it is my favourite graph, and it comes from Lithuania. And it starts in 1980, and it's the rate of death from heart disease in Lithuanian men under 65, or 60, I think it is under 65, and it finishes in about 2010. And from 1980 to 1989, it goes like this. And in 1989, it goes like this. And then it comes back down again, and it goes like this. And then you say to people, what happened in 1989? And they look at me, and young people like yourself think, well, what did happen in 1989? The Berlin Wall came down, and communism finished. And the social upheaval in these countries was astronomical, followed by an immediate spike in heart disease, a doubling, a trebling. In Russia, 2 years later, the same thing can be seen. 2 years later. Why did it happen 2 years later in Russia than in Lithuania? Because Gorbachev was overthrown by Yeltsin 2 years later, and the rate of heart disease goes like this. It comes like this. In 2006, it goes like this. It goes like this. You say, what happened in 2006? Putin was elected. Gigantic social upheaval is followed by enormous rates of heart disease. Now people say, I lived in Scotland, and say one of the reasons why you're interested in heart disease, because in Scotland, when I was doing medicine, Scotland had the highest rate of heart disease in the world. It no longer has. But what happened in Scotland was, in the late 1950s, early 1960s, the central part of Glasgow, 500,000 people were moved out of Glasgow and deposited in new towns around Glasgow, and the rate of heart disease went through the roof. And then they say, well, give me another country. In the 1960s, Finland had the highest rate of heart disease in the world. Finland, and you think, well, what happened in Finland? It's a little country out there, nothing happens in Finland. Finland suffered the largest forced migration of peoples in the history of the world, in a percentage terms.
Wow.
Because Russia said, we want that, and it's Russian, and they moved 650,000 Finns, which is not a big country, out of Finland, out of the Russian part of Finland, into Finland, displaced an enormous population. It was followed by an enormous peak in heart disease, especially in those regions that those people were put into. North Karelia is the northern part of Finland. So if you look around the world and you say, well, which countries in the world currently have the highest rate of heart disease? It's the previously communist states of Soviet Union. Top 10, I think it is currently. And then you say, well, which country do you think will be developing a rate of heart disease that's going up and up? Those recently developing, becoming modernized countries, India and China. Heart disease rates in these countries is exploding. All right. Well, part of that's probably pollution, and that has a rate, and there are other things. Everyone said it's to do with diet. It's got nothing to do with diet. You can see no dietary correlation whatsoever. If you take populations and you subject them to an enormous degree of stress, they will die of heart disease. If you look at, we discussed earlier, the Asian immigrant population here, if you put them into the risk calculator, you have to multiply by 2. Or is it 1.6? Anyway, very much higher rate of heart disease when all of the risk factors are the same. What can be causing that? Immigrant populations always have high rates of heart disease. In Sweden, the immigrant population in Sweden has a rate of heart disease 5 times as high as the surrounding population.
Wow.
The country with the population with the highest rate of heart disease is Australian Aboriginals. If you take an Australian Aboriginal woman and put their risk factors into a risk calculator, you'll be wrong by a factor of 30. They suffer 30 times as much heart disease as they should do according to the calculator. Other countries and other populations, generally the Maoris in New Zealand, very high. The Native Americans, I think they now call them American Aboriginals is the correct term you're supposed to use, which we used to call horribly incorrectly Red Indians at one point, but they're now very high rates of heart disease. Immigrant populations, if you take populations and subject them to stressors, the rate of heart disease it starts to go through the roof. We're the longest lived populations in the world. The blue zones, you may have heard of the blue zones, places where people live longer than anywhere else. There's places like Sardinia and Okinawa and Costa Rica and Seventh-day Adventists. These are coherent populations of people that support each other and have been living together for years. Well, Ikaria in Greece is one of the blue zones. The lifestyle there is different. I think communal support, good social interactions, a sense of purpose, friendships, family. These are the things that, when you look at them, really seem to hit hard. Hit hard, protect well. Dislocated peoples. If you look at postcodes, for instance, in Britain, I mean, you say postcode is a risk factor. Well, guess what? You could go through Britain and look at postcodes, and I bet if you had a pen, how many thousands of postcodes there are, you could put a little red thing saying, where do I think heart disease is highest? All right, and it will be disadvantaged people without jobs in what we call socially disadvantaged areas. And the same thing in America. There are postcodes, like one set of the tracks from the other, where people will live 10 to 12 years shorter or longer, depending on the postcode. And in Britain, I think there used to be a case in Glasgow, but I read somewhere they said it's not true, but it was 23 years between postcodes that were 1 mile apart. But it's not really the postcode, it's the lifestyle of those people, I'm lucky enough I live in a nice house in Cheshire, in a postcode that's probably, this is I'll never die of heart disease. If you moved myself up to Manchester 10 miles and went to Moss Side, and I put that risk factor calculation in there, and there's a very strong reality. It's not everything, but it's a really important thing. And I've looked more recently at heart disease, and what is the single, if you look at things, or just rates of overall death, if you like, that when you start looking at them, what reduces lifespan more than anything else is actually mental illnesses. Schizophrenia 22 years, depression 12 years, bipolar 15 years, things like these are real major things.
Wow.
The brain, body, the mind-body interaction is hugely important and almost entirely overlooked by the Western medicine. It's not just about fitness, it's not just about health, it's about positive mental attitude, it's about being happy, it's about having friendships and things like this. These are really important things. And people say, well, how can that cause a heart attack? Well, I can't take you through that here because it's very long and complicated, but you can see the exact mechanism by which it happens. People who are depressed, severe depression can cause type 2 diabetes. You can become diabetic, and if your depression goes, your diabetes goes.
Wow. The
power of the mind on the body is enormously powerful, strong, and it's just something we need to pay more attention to. If you ask me to say, should we worry about cholesterol levels, I'd say no, we shouldn't. We should ignore them. We should not bother testing it, all right? Because cholesterol is such an irrelevant factor. What we should be worrying about, yeah, definitely, is more to do with our overall. I say that health has 3 factors. It's physical, it's psychological, and it's social. And you've got to get all those 3 right. So if your physical health's wrong, the other 2 go wrong, etc., etc. But the psychological health, the stress, this is critical to health. Absolutely critical to health. So I would agree we should be worrying about stress. No, we should be worrying. We should be trying to be positive and do positive things with our lives and do positive things for other people. And we should be looking at that as where we should be focusing our efforts, definitely.